Greetings, Mathies. We are checking out the last piece of stats, choosing a regression, least squares regression. You already know how to put some of this in your data, in your stats button. For example, here's some percentage grades over the semester, and here's your absences. And no one is surprised that the person who's been missing 10 times has only a 30%. And most of the people who are missing no times have higher grades, right? 4 times, 67%. And so I'm guessing if we plotted this, there would be a correlation between absences and grades, right? And the more absences, the lower your grades. So I think it would do something like this. And we could plug in absences in your L1 and grade in your L2 and find a regression line. Right? Hopefully you're comfortable doing that. If not, check out the previous video. There's more than one way to run that line, and that's what this is about today. So I hope you're okay with finding the R value. If you're not, go check out that previous question. This would suggest that the data we put in had a negative correlation, which makes sense. The farther out on the absences, the lower down on your grades. And so a negative correlation just means that your line has a negative slope. And this 0.68 means it's like a moderate correlation. Not real strong, but not real weak either, right? Great. And so from that, we could, since I think we put in A as the X. So this was like absences, and this is grades. You could, if you missed 6 classes, you could put a 6 in there and multiply, and we could estimate somebody with 6 classes. So you go negative 3.7 times 6 and plus 68.5. I'm getting a 64%. And I know that you could, theoretically, run this backwards and say, if I need to get a 70% to pass, how many times could I potentially be absent? And you could run the equation backwards. And that works mathematically. But there's a better way to get an equation to predict your absences based on grades. We've been doing grade based on absences. And so this is where x on y, y on x comes in. So that's what we're going to look at today. If you haven't done this before, maybe turn on your scatter plot and we'll plot some data. I want you to be able to make a line and see your data scattered on there. So this is the heart of this piece today, is the idea of a y on x regression. This one versus an x on y. Notice that they're the same data. It's all the same data, all in the same orientation. This point, this point, this point, this point, this point. Right? I'm just kind of getting a smattering of data points. And I want to show you that they're in the same order. Oh, you stay. That. This still fits nicely right on here. So all of those data points, where are they? There you go. All those data points are in the same orientation. It's all the same data in the same location. This, if you ask your calculator nicely, is the equation for y on x. It means the y value based on the x. It means the grade based on the absences. So if I know I'm absent 6 times, what can I predict for my grade, right? And so this, your calculator will do this for you. You don't have to worry about how to calculate it. But the idea is that you can talk about this point that we're interested in, how far it is vertically from your line of best fit. Or you could talk about it horizontally, how far that same point is from your line of a different line of best fit. And so there's 2 different ways to talk about line of best fit based on x distance or y distance. When you're talking about the y distance, you don't necessarily need to know it's the y distance, but this is when we're interested in inputting an x and getting out a y value. We could turn around and see that you could put that a y value in and get an x value out, but usually if you run this backwards and you look at the horizontal distance, that's a better approximation. So we don't have to do this by hand. Our calculators are going to do this for you. But with this equation, we would put, well, I guess it's this equation. We would put the y value we require in this case a grade, and you get the x value out, the number of absences that you can have and still get that grade. Same data. This one's more accurate for predicting instead of running this one backwards. If the data is perfect, if all of those data points are perfectly on the line, i.e. they have an R of 1 or maybe -1 if it's downhill, these two will be exactly the same. This equation and this equation will be exactly the same. Let's look at an example, and maybe this will make a little more sense. Okay, so these are your English grades and your TOK grades. There's E and T, right? And 1 through 10, and also 1 through 10. So first, I put these all in a list like this. Oh, sorry about that. Stats. There we go. That's better. Here's 2, 3, 4, 4, 5, etc. 2, 3, 4, 4, 5, etc. 4, 5, 4, 6, 4, 5, 4, 6. So I put these all in. I'd like you to do the same. Just toss them in your stats, and then we're gonna walk through something together. I want you to be able to make this graph appear, basically. And so first we're going to make a y on x, which is just kind of the normal equation that we'd expect. The y on x is you put in an x value and get out a y value. So in this case, you can keep typing while I'm talking. Let's change these colors. Let's call this one purple for E for English, and this one red for TOK. So since the English is on the X, this is E, and this is T. And let's get rid of this for a second. Okay, so far you put that data in, you said stat, you said calc. I'd like you to calculate me a linear regression, please. Beautiful calculator. And I said let X be list 1 and Y be list 2. I'm going to store my frequency regression in vars, y vars, function y1. So it's just going to take that equation, put it into y1. And if you calculate, ba-boom, should give you this same thing. Right. So here's my slope, my b value, 0.82, positive correlation, fairly strong. Great, that's that part. And if we graphed it, I'm going to say zoom stat. There it is. Oh, get rid of that one. Don't look. Avert your eyes. All right. And also, I'm going to change the window. I want to see the axes. So I'm going to just make those to -1 so I can see the axes. There's my data, and there's the line that goes through it. And then I know that this is the English point. I might take a screenshot of this and put it in here so I can ignore the 2 lines for a second. So this is TOK value based on English. So if I knew what I was going to get in English, if I knew I was going to get a 6, no, let's do an 8. Who am I kidding? Let's do a 4. I'm not an English person. I would go to 4 on the English, go up, find that value, go over, and that would be my TOK. Right? And so from this equation, you can do that by saying second calc and value. And notice I'm putting in an X value. That means I'm putting in an English value. I put in a 4 because I'm a math teacher and I don't speak English good. And it tells me the Y value is 4.9, so a 5. Okay? That's good. And I know that there are techniques like run a vertical line to be able to find the, if I knew my, if I ran this backwards, and I knew my TOK was a 10, 9. If I knew my TOK was a 9, I know we could run a vertical line and find this and then find the English based on that. And that totally works. But it's not as good as running a X on Y regression. And an X on Y regression is going to look like this. All we're going to do is instead of list X is in list 1 and Y is in list 2, we're just going to switch that around. Right, so we're going to do the same thing on the calculator. I'm going to say stat, calculate me something please, linear regression, just like normal, but we're going to go second, list 2, switch this to second, list 1, store my regression. I'm going to put that regression in 2. So it spits out a different equation for me. And I'll show you an interesting part of this in a second. Decently similar R value, right? Same R value, but when you graph it, there's our first line, there's our second line. They're not the same. I'm going to turn off this one for a second and just look at this new equation. So if we ran the graph now, the equation now, we're asking it about what the TOK value is. If we know the TOK value is, what is the English? So now we can say second calc, I know my TOK value is 10, and what's the other value? So what's the English value? So 9.15. Okay, so this equation is X on Y, means if I have Y values, it'll tell me the X value. This one says if I know X values, it'll tell me the Y value. And you could run either one in reverse, but this is a better approximation if you know the Y value that you have, and it spits out the X value. Same data, just color-coded, is here, right? And this is the Y on X, this is the X on Y. You just say it like you see it, right? Y on X, X on Y. One thing that I want you to notice is if you take this and you try to solve for X effectively, you don't get the same equations, right? If you subtract, 1.9 and then divide all of it by 0.764 to get X, you end up with X is Y 1 over 0.764 divided, so you get 1.3Y minus that 1.92 divided by 0.764 minus 2.51, right? And this equation and this equation are not the same. This one's going to be a better predictor of Y values if you know the X value. And instead of calling them Y's and X's, maybe let's call them by T's and E's. They're not going to be the same because, again, one is created by looking at the distance vertically from points, and the other one's created by looking at the distance horizontally. Not that you need to know that part, but and so, you know, depending on which one you use, you can get a different value out for your prediction. And so, like, you can use this as a statistician to your advantage. If you knew you had a 9 for your English grade, and so you should use this pink one because you're inputting a 9, so you're going up to here, and this is a better approximation if you know E as your input. Your T should be a 10, right? If you use this one in reverse, you'd say, oh, 9, oh, I should get out a 9. But that's not as good of a prediction statistically, right? So instead of running them backwards, like if you were going to use this and knew the 9 was the E, you'd put 9 into here and run it backwards. So that's effectively what you're doing with this one, right? And this gives you the T when you output this. This gave us a 9, but this gave us a 10. So which one would you rather use? Well, this is more statistically sound since our input is the E value. You should use this one because the input is E. You should also use it because it gives you a better value prediction. And so you do have to take some statistics with a grain of salt, look at people's models, and think about what they're doing. Okay, so let's use that data. We did this. We found a regression for y on x, x on y, show both lines on a scatter plot. We did that. So find the predicted TOK score if you scored a 9 in English. And so, well, I guess we already did that. This is an E value. We'd put it into the E here, right? And then solve for that. And so we got 9. And if we had in this, they said 8 in TOK, we put the 8 into the T equation to get E. We could have put it into here and backwards solved, but that's less of a solid prediction, right? And so when you put 8 in there, you should get 7 out. Cool? That's it. Try some practice problems when we get in, and we will see you later.